You might be wondering what those tripods are and what are these white squares that they carry. Soon you will know everything. Hi, I'm Egor, and today I'm going to tell you about uncertainty and traceability, the topic of Senseco Working Group 4. Let's get started. Uncertainty is an inevitable component of any measurement, but we have to understand how large the measurement uncertainty is. First, we have to understand what are we measuring. We usually say that we measure reflectance, and reflectance spectral signatures of different components is different. But this is wrong. We never measure reflectance. We calculate it. What we measure is actually incident light and reflected light, and the ratio of those two is reflectance. We measure the light by counting photons and converting it to digital numbers. This is level 0 or raw data. A conversion and correction has to be applied to convert it into radiance, and only then reflectance can be produced, after which the products. You can see the difference between level 1, 2, and 3 on Sentinel-2 image. Level 1, 2 has clouds, level 2 is clear surface reflectance, and level 3 is product already. But first, radiometric corrections are applied, converting digital numbers through radiance to reflectance. For this we need reference, instrument, atmosphere, and BRDF. Again, reflectance is a ratio of reflected and incident light, and it's possible to measure both at the same time with the spectrometer that you see on the left. Its scheme and how it looks like in real life. But more often, what we use is we measure first a target and then the reference with the same spectrometer. And the reference is the white panel. For example, in this measurement, you can see the white panel is right behind the researcher. Spectral quality of the white panel quality is the source of uncertainty because it's never completely white. Here you can see the difference between clean and not clean white panel. There are also gray and black panels for drone flights. Then the instrument uncertainty is a spectral response function because we are measuring continuous spectrum, but the measurements are discrete. So every time the spectrum will be distorted. For example, here are the 4 channels, red, green, blue, and near infrared of the Landsat instrument, and on the right is of Sentinel-2 multispectral instrument. You see, although it's still red, green, blue with the same central wavelengths, they actually sample different portion of the continuous spectrum. The atmospheric effect is inevitable in Earth observation. What we're interested in is surface reflectance, but unfortunately we always get scattering from clouds and aerosols. And you can see the difference between atmospherically non-corrected level 1 image and atmospherically corrected level 2 image. In SECO, there is atmospheric generation toolbox on the channel that can provide atmospheric correction tools. BRDF is the last effect we have to consider. We think that the surface is ideal and reflects equally in all directions, but of course that is not true. Actual surface always has BRDF. For example, this field has this dot, but there is nothing unique about that dot besides the fact that the sensor was aligned with the illumination, and of course BRDF has to be removed and avoided. Then, geometric correction is what makes scientific data from the image. So the image is just an image. It has to be first georeference, so latitude and longitude has to be assigned to pixel, and then all pixel has to be equal in size. What can follow is the comparable time series of different sensors or of similar sensors on board of different satellites, because now they are in types A and B, and harmonized time series of completely different instruments. That is the power of knowing the uncertainty. Uncertainty is a topic of Working Group 4, led by Andreas, Laura, and Agnieszka. They provide best practices for calibration and validation datasets, software packages for uncertainty and stability, for example, of SpecU database, and the quality assessment tools. Well, this was uncertainty topic in remote sensing. Thank you for your attention.